North Star Steel is one of the most important American producers of alloy steel bars and wire rod for the domestic mechanical industry, with a productivity of 2,200,000 short tons per year. North Star Steel Company has decided to invest in a new rolling mill to improve both productivity up to 3 million short tons per year and final product quality with the aim of strengthening its position in the home market and exporting to Canada and Mexico. The process starts with the ContiCaster, where starting material is created. Square billets pass through a walking beam furnace before the effective rolling process. The billet size is 165 by 165 millimeters, with a length of 14,630 millimeters and a weight of 3,130 kilograms. The rolling mill is fitted with 18 cap stands, a new generation of housingless stands. Optimum standardization and a minimum number of components minimize spare parts stock in order to offer customers flexible and cost-efficient solutions. The mill train is arranged over 3 different stand groups: the roughing mill, the intermediate mill, and the finishing mill. The walking beam cooling bed introduces the finishing services for bars production. The finished product goes through automatic sub-bundling and master bundling station. The bars process ends with tying and collecting services. In order to extend the product range, North Star Steel installed on this plant, in parallel with the bar mill, a wire rod line capable of reaching 120 meters per second. This new product line is equipped with the latest generation of Danieli Morgutshammer machines, including a 10-stand Delta wire rod block, a controlled cooling line with DSC Danieli structure control process, and a loop layer designed for 140 meters per second. Finishing facilities are introduced by a collecting pit on a vertical trestle, an overhead C-hook conveyor, a compacting and tying machine, a weighing system with a coiled discharge station. An important feature of the DSC process, in order to control the finishing rolling temperature, is the pre-box concept. The temperature of the rolled stock must be reduced before entering the wire rod block for avoiding excessive heating due to the high finishing speed. The system consists of a water box located upstream the rod block, where a series of tubular elements are installed. The bar travels inside these cooling elements, where high-pressure water is sprayed through a ring-shaped nozzle. The bar is thus radially surrounded with water, and the whole section is evenly cooled. Downstream the water box, a free area is provided to re-equalize the bar temperature before undergoing the subsequent deformation in the rod block. The new Delta wire rod block is of compact design, where great attention has been paid to the stiffness and simplicity of the stands to meet the demands of high speed rolling, high production, and close tolerances. Main features of the Danieli finishing blocks are modular composition from 2 to 10 passes, Modules arranged at 45-degree axes. Fixed rolling line. Interchangeability of ring carrying modules in right-hand or left-hand configurations. Cantilever mounted carbide rings for longer life, maximum finishing speed, and maximum section reduction. Simultaneous and symmetrical adjustment of ring center distance. A unique concept of locking and unlocking rings to reduce the possibility of ring breakage. The rolling rings are cantilever mounted on their shafts. Radial clamping and centering is carried out by means of a conical bushing provided with expansion lugs for a flawless matching with the shaft. The ring is locked by means of hydraulic equipment. The ring size assures a long life of the ring against thermal and engagement shocks. They can be provided with 2 rolling grooves. Ring cooling is carried out by 2 headers located in the block itself, designed to cope with any cobbles. The working pressure is 6 bar, and tightness is assured by O-rings. The wire rod block is driven by 2 DC motors. The reduction synchronizing gearbox is designed as a sturdy unit. The gearbox is made of thick steel plate for soundproofing purposes. The Delta wire rod block base plate is a monolithic box structure of thick steel plate. The particular box design makes the base plate very stiff and capable to cancel and take up any vibration whatsoever. The machine is fully enclosed by a monolithic guard. A manually operated mechanical safety assures that the guard does not close because of a wrong operation while the rings are being changed. An electrical safety stops the machine should the guard open during the rolling process. Coolers are installed between the stands to cool and guide the material. The water flow rate is adjusted as a function of the rolling speed and section of material. Opening and closing of water flow is controlled by a computerized system. A cobbles box is located between the last unit and the cooling water line and is used as a breakout point. A photocell inside the box controls a safety shear with cutting capacity up to a diameter of 26 millimeters. A safety wire placed within the box along the whole rolling line in case of cobbles involves the immediate cutting of the material by means of the safety shear located before the wire rod block. Each steel grade and each product needs a convenient rolling temperature and temperature drop before coiling. The DSC, Danieli Structure Control System, mainly consists of accurate control of the rolling temperature, starting from the reheating practices down to the very end of the rolling process, water cooling system located in the strategic spots of the mill, final controlled cooling of the wire rod, executed after coiling onto the roller conveyor. The water cooling line consists of a series of water cooling boxes and temperature re-equalizing areas located between finishing block and laying head. It is used to rapidly and evenly cool the wire rod, emerging from the finishing passes down to the required coiling temperature range, to control gain growth and to pilot type and layer of scale to make it suitable for the descaling process. The layer temperature can be completely controlled from the finishing temperature down to 800 degrees and, where requested, from the production mix down to 760 degrees or less, avoiding any martensite formation during water cooling. Inside each water box, the wire rod cooling is done by high-pressure water sprayed inside the tubular elements through a ring-shaped nozzle so that cooling water surrounds the bars and the whole section is evenly cooled. The number of operating elements, the pressure and flow rate of the cooling water varies depending upon the desired temperature decrease and hence according to the quality of rolled product to its speed and diameter. Each water box is provided with a series of cooling nozzles and with high-pressure water strippers. Air dryers are located in each water box to completely remove any residue of water on the bar. The whole line is controlled by a PLC interconnected with a human-machine interface system. On the basis of the rolling cards inserted and on the temperatures readings of the pyrometers placed at strategic spots, the PLC provides for the automated real-time regulation of the system. A pinch roll is placed in the middle of the water cooling line. The aim is to divide in two parts the distance that small size rods have to travel free to reach the laying head, thus reducing front-end vibrations, ensuring smooth rolling and decreasing uncooled front end. In the equalizing areas, the thermal gradient between wire rod surface and core is equalized before any further cooling, be it by water or by air. The dimensional range of products is divided in groups so that for each group, the same set of coolers, strippers, and dryers can be used. The cooling nozzle and stripper have adjustable gap, but water flow is controlled during rolling by means of the flow modulating valves. A turn forming head uses a new concept developed for coiling, quenched and tempered products with diameter of up to 16 millimeters. The loop layer is designed for 140 meters per second. A controlled cooling roller conveyor downstream the laying head is used to evenly cool the rod across the transformation range at such a rate to enable the steel to achieve the desired mechanical and metallurgical characteristics. The roller conveyor is divided in sections of 6 meters each. The product requires the proper speed setup for each section in order to obtain the proper cooling rate. The linear speed of wire rod loops spread onto the roller conveyor can be varied in order to set the correct package to execute proper cooling mode. The high-blowing power system consists in a series of powerful fans installed underneath the roller conveyor. The setup of these controlled cooling devices depends on the steel grade, the wire rod diameter, and on the desired mechanical and metallurgical characteristics to be achieved on the final product. Cooling process is controlled by a HMI system. When subjecting wire to air blowing onto the roller conveyor, there is the need to diversify the amount of the air blown from the fans at conveyor sides in respect to the conveyor center. This in order to adapt the distribution of the airflow to the distribution of the wire rod through the conveyor width. To this aim, V-shaped flaps are installed for each fan underneath the roller deck. In the wire rod finishing area, the coil turns fall down into the collecting pit and then in the coil forming and transferring station. A rotating platform transfers the vertical trestle with the coil to the discharging station. A hydraulically controlled tilting device puts the loaded coil carrier in horizontal position. A liftable and lowerable car charges the coil into the C-hook conveyor. The power and free conveyor is driven by a power chain system to which the C-hook can be connected and disconnected in relation to the operating cycle. A coil compacting and tying machine is located before the weighing system. An electronic weighing device with liftable platform weighs the coil before its final discharging. Finally, the unloading station, where the unloading car transfers the coil to the collecting station. The whole complex is controlled by a Danieli Automation Level 2 fully integrated automation and process control system. North Star Steel is one of the most important American producers of alloy steel bars and wire rod. Danieli equipment and process know-how empower it to further strengthen its position in the domestic and foreign market and to become a production cost winner.